Okay, so we're going to talk about solving radical equations. So what we're going to try to do here first is we want to get the radical by itself. So I'm going to subtract 3, did minus 3, gives us 16. Now I want to get rid of the 2, so I'm going to divide both sides by 2. Divide this by 2, then this by 2. Now once I have that, I need to get rid of the square root. Can't do anything with that until I get rid of the 3 and the 2 there. If I get the radical by itself, how do I get rid of a square root? I'm going to square both sides. We raise both sides to the power of the index. When the index in this case is not written, but we understand it's 2. So I'm going to square both sides. Over here, it'll just cancel out. Over here, I'll get 64. And then you just basically solve. So add 1 to both sides, so x is 65. Now on these, we're going to come across some problems. You need to check your answer. Does 65 work? There's going to be times where, because we're squaring these square roots and the properties of square roots, we might get extraneous solutions. So we check our solution. I'm going to plug 65 right back in here. And basically, you can throw all of this in the calculator and see if it comes out to 19. So it's 2 times 8 plus 3. So it is 19 equals 19. That's good. So our answer, 65, is a valid solution. So always check for extraneous solutions. Square roots end up giving us extraneous solutions sometimes. Okay, let's try another one together. And then I'm going to have you do one. So we're going to start by getting the radical by itself. So I'm going to subtract 3, minus 3, minus 3. Now I've got my radical by itself. I'm going to square both sides. The most common mistake is people not squaring the 7. They'll say, oh, this all cancels out, and they'll write 2x minus 7 equals 7. So that's a pretty common mistake right there. So be careful of that. So now I'm going to add 7. I'm going to divide by 2. Get x is 28. So I need to go back and check that. I'm going to plug it in right there. Again, you can just throw all of this in your calculator. We're not really checking you can do all the math, but you're going to find out 10 equals 10. The other common mistake is people then putting in 10 as their answer. This statement just means this is a valid answer. 28 is a valid answer. In this case, the only valid answer. Okay, you work this one out. Pause it here, work it out, come back and check your answers. Okay, so I subtracted 13, divided by 3. Now I'm going to square both sides. And I'm going to get x minus 9 equals 1. I'm going to add 9 to both sides and get x is 10. So I'm going to plug 10 back in right here. And I throw that in the calculator. I'm going to find out the left side turns into 16. 16 does not equal 10. So therefore, 10 is not a valid answer. So we have no solutions. X equals 10 is extraneous. And the problem comes in, you can actually stop right here. There's nothing I can take the square root of and get -1. By definition, a square root function is the non-negative solution, non-negative root. So right there, if you come across this, you can stop. But if you're not sure about it, you keep going. And the problem comes in when you square both sides, that becomes +1, and that's where it gives us this false answer. Okay, let's make it a little weirder. So my radical is already by itself. I don't have anything I can do there. Now I see I have an x over here. So the problem is I'm going to square both sides. But I can't, this is not just x squared plus 9. We have to go and take care of x plus 3 squared. That's x plus 3 times x plus 3. You got to do all the foiling, all of that. this is one of those patterns you just got to start getting used to. And we're going to get that x plus 3 squared is x squared plus 6x plus 9. Square the first one, double both of them, square the first one, double both of them, square the last one. So now I'm replacing the square, gets rid of the square root, and now I'm replacing x plus 3 squared with all this. Now, normally we would get all the x's on one side and the numbers on the other, but when we have an x squared, this becomes an old quadratic. We want to move everything to the right. When you have an x squared and other x's, you want to get everything equal to 0. You want to move all of this over to the right. So I'm going to start by subtracting 17, just so you can see what we're doing. Now I'm going to subtract 8x. And get that. Now I factor. What multiplies to negative 8 and adds to negative 2? It's going to be negative 4 and positive 2. Now I have a number times a number equals 0. That means one of these two numbers has to be 0. So this is a number and this is a number. What would make this 0? X being 4. What would make this 0? X being negative 2. Now you have to go back and check both of them. So let's check 4. And we find out we get 7 equals 7. That's good. So x equals 4 is an answer. Let's check negative 2. We get 1 equals 1. That is true. So we have two solutions. X equals 4 and x equals negative 2. Okay. Going to have you try this one. Pause this one here, work it out, and then come back and check your answers. Okay, so we square both sides, and we got to do x plus 6 squared. Remember, you're going to get this squared, double both of them, and then square that one. So it should be x squared plus 12x plus 36. So the square root and the square cancel each other out, and we're left with this. Now I'm going to subtract 12. Then I'm going to subtract x. So what multiplies to 24 and adds to 11? It's going to be 8 and 3. So then my two solutions are negative 8 and negative 3. So we have to go back and check them. Plug in negative 8 here and here. And we get 2 equals negative 2. So that is not a solution. So plug in negative 3. Now you end up with 3 equals 3, which is true. So this is my only solution. Okay, one more. Try this one, pause it here, work it out, come back and check your answers. Okay, we square both sides. Hopefully you can figure this out by now. X squared minus 14x plus 49. So now I'm going to subtract 39. I'm going to add 7x. What multiplies to 10 and adds to negative 7 is negative 5 and negative 2. So my solutions are positive 5 and positive 2. So let's plug in 5. And we get 2 equals negative 2. So x equals 5 is not a solution. I'm going to plug in 2 and get 5 equals negative 5. So 2 is also not a solution. So that means we have no solution. There's no value of x that makes this true. Okay, that is it. Good luck.